Hello, class. I have a Unit 1 test review here on the screen. A survey of 1,500 American households found that 33% of the respondents own a computer. This is based off a survey of 1,500 American households out of 3,000 American households sent this questionnaire. And as I asked here, this 33% is it a statistic or a parameter? And in this particular case, this is going to be a statistic. And I would want you to identify the population of the sample as well. So in this case, this sample, for example, would be the 1,500 American households. American households. And then right underneath that, I asked about does this survey constitute an observational study or an experiment? Based on the way this is written, this is going to be an observational study. Observational study. My second question is to identify the level of measurement for these variables. So nominal, ordinal, interval, or ratio. Address number. While you can certainly, it names and everything, but adding and subtracting does not necessarily mean you have a new address number. So the only one that best describes this one is going to be ordinal. For the number of items in a shopping cart, you could certainly have 0 items in a cart, and that does mean empty. And the multiplication and division does make sense for this one, so this would be a ratio. And my third one, I gave television station, television channel numbers. So when you change the remote stations, this is going to be an interval level of measurement. Since having a station of 0 does not mean the TV is off or anything. Does mean it's staticky, yes, but that does not mean it's, off or something. So those are those three. The third one. I want to identify the population and sample in this scenario. A retail store manager wishes to find out what her customers like about the store. So she obtained a sample of 50 customers to ask what they liked about the store. And we wanted to, again, identify that population and sample. So the sample is going to be the 50 customers that she asked. While the population are going to be all of the customers. So all customers. All of the customers for that one. The fourth one. A man surveyed a sample of 36 high school students and asked, how many days in the past week have you consumed an alcoholic beverage? And the results of this survey are given in this histogram. So it shows the number of days of consumption of alcoholic beverages. It gives a whole bunch of data. And the first question I ask here is, what shape is this histogram? So this particular histogram is going to be one of of those skewed right distributions. Skewed right. And another question asked about is based on its shape, which skewed right for this. The measure of the central tendency that you think is greater, so mean or median. So because of the skewedness, it pushes the mean to the right, so it increases it. So the measure of central tendency that's greater is going to be the mean. So moving on from there, I gave this particular, not data set, but these summary information, which is the average and median high temperature in degrees Fahrenheit and the low temperature in degrees Fahrenheit for Fairfield, Connecticut, during the month of during the month and year of December 2020. And based upon these particular values, I put that according to the Old Farmer's Almanac, the high temperature in Fairfield on December 31st was 34 degrees Fahrenheit, and the low temperature was 12 degrees Fahrenheit. Based on these values, we want to calculate the respective z-scores for the high and low temperature, rounded to 2 decimal places, and interpret with an asterisk because, well, there are no units for this one. But interpreting those two values. So, to do this particular calculation, let's start with the hot temperature. So 34. Oh, just to also make note of the calculation before I fully write this. For the z-scores, this takes the observation minus the mean divided by the standard deviation. So 34 minus the mean for the high temperature of 44.41935.484. All divided by 9.02505.4731. So rounding that to 2 decimal places, this makes negative 1.15. So the z-score for the high temperature is negative 1.15. For the low temperature, and this is going to be 12 minus 30.225 806.45 divided by 6.489 528 372. And this makes negative 2.81. When rounding that to 2 decimal places, and the interpretation of that, again, no units because it's a unitless measurement. The z-score for the low temperature temperature is, this would be negative 2.81. And the second part to this question asks about which z-score is colder. So which z-score is lower. In this case, will be the low temperature. Low temperature. My next question, number 6. I have the distribution of ACT scores for high school students in the United States is normally distributed with a mean of 18, standard deviation of 4. And based on this, we want to know the approximate percentage of ACT scores within 1 standard deviation of the mean. So 18 plus and minus 6. Excuse me, plus and minus 4, not 6 for that. There we go. 18 plus or minus 4. So when you subtract, this makes 14. And when you add, that makes 22. And based upon that fancy schmancy empirical rule, because this is indeed normally distributed, this would be approximately 68% of the data for 1 standard deviation. So 68% of ACT scores will fall between 14 and 22. For that 1 standard deviation. Moving on from that one, we have the 2 standard deviation next. So this is 18 plus and minus 2 times 4. So adding and subtracting 8. This will make, when you subtract 10, and when you add, a value of 26. So this would be approximately 95% for the 2 standard deviations. Approximately 95% of ACT scores. ACT scores will be between 10 and 26. This next one wants 3 standard deviations. So for this one, 18 plus and minus 3 times 4. So the low one for this is going to be a value of 6. And the high one is going to be a value of 30. When you subtract and add, respectively. So for the 3 standard deviations, this would be approximately 99.7% of ACT scores will be between. This would be 6 and 30. My fourth part to this one asks one of those percentages inside of the empirical rule, this one being between 26 and 30. So, for this, might be helpful to at least glance a little bit at that empirical rule. Let's call that mean of 18 here. One standard deviation, let's say, is here. That when we had that value of when we added 4, that was 22. Because this is symmetric about the mean, this area between 18 and 22 is 34%. For the 2 standard deviations, so this went up to 26. The full 2 standard deviations is 95%. So for half of it, take half of that 95%, which is going to be 47.5%. And since we already have 34, when you subtract the 34, you get this value here, which is 13.5%. For the 3 standard deviations, the one that goes up to 30, the full thing is 99.7%. And since, again, we're talking about just half of it, the half of that is 49.85%. So since we already have 47.5% in there, when we subtract that from that 49.85, that gives this value here that we're looking for, which is going to be 2.35%. So the ACT scores that lie between 26 and 30, this would be approximately this would be 2.35% of ACT scores will fall between this would be 26 and 30. And for the fifth part of this, at least. What percent of ACT scores fall within 2.1 standard deviations of the mean? Because of this at least, this is that Chebyshev's inequality. So 1 minus 1 over. This would be 2.1 squared times 100%. You toss that expression into a calculator, and you should get an answer that rounds to be to 2 decimal places, 77.32%. And I'm also going to want the range of values. So you need to take 18 plus and minus 2.1 times 4. So subtracting gives 9.6. And adding gives 26.4. So to write that out, this would be at least at least 77.32% of ACT scores will be between this would be 9.6 and 26.4 based upon these values that I gave. Again, due to that at least, that would be that Chevy-Chev's inequality that we talked about. This next one deals with contingency tables. Based on this, which is on a handed data set based on gender for the row variable versus column, what hand that is your dominant hand, so left hand versus right hand. We want the marginal distribution, so just add these. 4 plus 9, this will give us a value of 13. For 44 plus 43, this will give us a value of 87. 4 plus 44, this is 48. 9 plus 43, that makes 52. And you can add either the row or the column to get this last value, which should be 100. Part B wants the absolute proportion for female right-handed people. Interpret it, round to 2 decimal places. This one you actually don't have to round. So for female right-handed people, this is going to be 44. And since this is out of the absolute proportion, it'll be out of the 100. So 44 divided by 100. So in this case, 0.44 or 44%. So the absolute proportion proportion of, this will be right-handed females right-handed females is 0.44. Part B wants the absolute proportion for male left-handed people. So male left-handed, again, absolute proportion. So 9 divided by 100, or 9%, or 0.09. So for this one, again, the absolute proportion absolute proportion for left-handed males left-handed males is, this would be 0.09. And so, again, based on the same as that table, part D wants the conditional proportions based on gender. So the right-hand column there, the one that had total, all three of those are going to be 100%. So just to make note of what we're doing. For the female row, we're dividing by the total for the female row, which is 48. For the male row, we're dividing by the total number for the male row, which is 52. And for the total row there in the bottom, we're dividing by 100. Just to point out where these numbers are going to be coming from. So for the left-handed females, so in this particular case, dividing by that value of 48, rounding this to, we're going to do 2 decimals, so 0.08. For right-handed females, 0.92. For the left-handed males, dividing this time by 52, 0.17. For right-handed males, again divided by 52, 0.83. And then dividing the 13 by 100, this makes 0.13. And dividing A is 7 by 100, this makes 0.87. And then part E in the bottom, I want to know, does there appear to be an association? Which in this case, there does seem to be a decent one there. For both males and females, males and females, the right hand is dominant. Right hand is dominant. Okay. So let me know if any of you have any questions, concerns, or anything. Otherwise, have a good rest of your day, and I will see you for this test on Friday. Thank you and have a good day.